welcome back to part 2. Now, before we were looking at rolling a dice and doing a spinner. And notice that you might want to remember, and we multiply. Because now we're going to be talking about mutually exclusive events, and we'll treat them a little bit differently. What do I mean by mutually exclusive? What mutually exclusive means, if I do one thing, I cannot do these others. One of them is dependent upon the other. Okay, so yeah, they cannot occur at the same time. For example, you cannot roll. If you roll a 2, you are not rolling a 4. But you could find the probability of rolling a 2 or a 4. Does that make sense? You're not doing two separate items. Yeah, they cannot occur at the same time. Hopefully you'll see the difference as we get into some examples. The probability of rolling a 2 or a 4. Since the dice cannot show both a 2 and a 4 in one roll, these events are mutually exclusive. And here's a Venn diagram. Here's the probability of rolling a 2, and here's the probability of rolling the 4. And notice there's no overlap, because if you roll a 2 is not a 4. They don't overlap. In this situation, when you have mutually exclusive events, you add the probabilities together. So this is the tricky thing. When you want something and something to happen, like rolling a 1 and spinning a 3, we multiply the events. When we want this or that to happen, we add the events. So let's look at some specifics now. For example, Alfred's going to go pick out a new pet. And when he went to the animal shelter, he saw that they had 8 dogs, 7 cats, and 5 rabbits. So if he just picks an animal, he just closes his eyes and points, what's the probability that he would choose a cat or a dog? See, he's only going to choose one. So those are mutually exclusive. So what we have to do is calculate the probability of him first choosing a cat. There are 7 cats, so there are 7 outcomes we want. How many total animals are there? 8 plus 7 plus 5, that's 20. There are 20 different animals, 7 of them are cats. Now, what is the probability of selecting a dog? There are 8 dogs in 20 different animals. And remember, in this case, because he's only going to take one pet, but what's the probability that that one will be a dog or a cat? We will add them together. 7/20 plus 8/20 equals 15/20. Or if we want to be the most precise, we would simplify that fraction down to 3/4. He has a 3 in 4 chance of choosing a dog or a cat, or 75% chance. Okay, here is another example. The French club has 16 seniors, 12 juniors, 15 sophomores, and 21 freshmen. So what's the probability, if you choose one at random, that they're going to be a junior or, notice that word, or, that tells us we're going to add a senior? Well, what's the probability that they're a junior? There are 64 total students. 12 of them are juniors, so he has a 12 in 64 chance of selecting a junior. What about the probability of selecting a senior? There are 16 seniors, so a 16 in 64 probability of selecting a senior. Add the two fractions together and you get 28/64, which simplifies to 7/16. There's a 7/16 chance of selecting a junior or a senior. Okay. In this situation, what is the probability that if you had a deck of cards that you would select a king or a diamond? That or is there, we're going to add. So what's the probability you'll select a king? Well, in the deck there are 4 kings, so we have a 4 in 52 chance. How many diamonds are there? 12 in 52. We can simplify those down and we come up with 4/13. Now you'll notice here I kind of hesitated because I was like, wait, there are 13 diamonds? Yeah. See? There's a king of diamonds and he can only be counted once. So that's why that second one is not 13/52. Okay. So in this case, what is the probability of flipping a coin and getting a heads? And notice there's just that little comma, so that's an and that means we are going to multiply. Probability of a heads is 1 in 2. The probability of drawing a heart is 4 in 52. Or let's simplify that because we're going to have to multiply, and I don't want to have to multiply 4/52 if I don't have to. 1 in 4. Multiply across like a boss. 1 times 1 is 1. 2 times 4 is 8. There is a 1 in 8 chance that if I were doing both of those events, one of them at least would that they would turn out the way I want. I would draw a heart and I would roll a head. Flip a heads. Okay, what is the probability of flipping a coin and getting a tails? 1 in 2. What is the probability of rolling a dice and getting a 4 or a 5? Well, that's 2 possible outcomes of 6. 2 of what we want, a 4 or a 5, out of 6 outcomes. We can multiply across, or we could simplify first. 2 divided by 2, that gives us a 1 in 6 chance of having a tails and a 4 or a 5. All right, what's the probability of getting a heads or a tail? 2 out of 2. What's the probability of getting a face card? How many face cards are there? Jack, Queen, King. Ooh, now tricky. Are we going to count an ace or not? There's not a face on it, so I'm not going to count that. Jack, Queen, King. There are 3 face cards in each suit. There are 4 suits. So there are 12 possible face cards out of 52. Oh boy, is there some simplifying we could do? I think there is. 2 divided by itself goes 1. 1 into 52 goes 26 times. 1 goes into itself. 1 goes into 12 6 times. Whew. Already we've got 6/26. That's a lot easier to deal with. We could simplify it some more. 2 will go into 6 3 times. 2 will go into 26 13 times. There's a 3 in 13th chance of getting a heads or a tails and getting a face card. All right. There we go. There's an introduction to compound events. I will be back in the office on Wednesday. If you have any questions, send me a K-mail. Go ahead and pause and rewind the video as much as you want. And again, I'm only a K-mail away.